second year, I started working on some project, and like, and I was in parallel. I was taking courses from NPTEL as well as edX, and from there, like I got some ideas. And in third year, I published one of my paper, and then apart from that paper, I started working on the other project, which is basically a pet project from edX course. And then advancing that one, I was able to publish a journal paper by the end of the fourth year. So within the term of my BTech, I had two papers. And with that research profile, I was I was more I was feeling more uh, established, and I was thinking that, okay, can I do more challenging research? So on my own, I started working smart city related project. And since then, from 2015, I guess, so I was working in smart city domain. And I did masters in robotics from KAIST, and now PhD student at KAIST in South Korea. So the same research is still going. So now I will be presenting. I will just giving you the gist, like not the technical details, but just the ideology, what I am doing. And any student, if you have any query, just raise your voice and ask some question. Like it is like you can ask and make it one-on-one interaction, not like just I'm giving the lecture and you are listening. So yeah, so the topic is multimodal data usage for smart city use case, especially traffic surveillance. So what is a smart city? Smart city is like sustainable, connected, and livable city. It uses communication technology for providing services such as traffic management, environment monitoring, and many more. You can see in this picture. So this communication thing happens with internet of things. So IoT technology handle urbanization with minimal impact, and help with all these application. Because once you give some data, then that data will get processed, and accordingly the facility will be provided. So all is uh, like the major deal is data here. So what is smart mobility in smart city? Because there are so many services, but now I am more keen on focusing on mobility. So the thing is, in cities, more and more population are coming, and city population is growing too fast. And by 2050, two-thirds of the population will be residing in city. But the area of city is only 20 to 30% of total area in any country all over the world. So basically what we are doing is we are growing our city in 3D. We are making building one floor over the other, but we have road in 2D, like only the road layer is only 2D. We are not making the roads in 3D. So like there is some bottleneck here, and hence mobility need to be assisted. So what are the smart city attributes? So these are four main vertical that is always focused for planning and execution of any policy. So mobility for quality of life, smart mobility, infrastructure development, sustainable mobility policy. So there are sub point, and this I will tell you where you can get this PPT later if you want to see the content. So the information and communication technology is at the core of mobility, as I have told you, uh, how you share the intelligence with your smartphone, and then it is processed by some data management server, and then some application handling is done to give you the service. So what are the challenges of ICT mobility services? For example, you are giving your personal data. So here there can be security issues. So the security issues are related to security and privacy challenge, operation cost challenge of ICT, and challenge based on user base. So mainly the security one is prime, and on that I told you that I published one paper in second year of my BTech. So uh, in the last of second year, not the second year. So the thing is like. I write this particular paper, network security protocol for constant resource devices in Internet of Thing. So how you can give in and log in the credential and then share your data on some low cost Internet of Thing devices. So it is all about that. You can go through that paper and check what are the different things. So here today we will talk some little gist of the research domain, not rather particularly technical of one domain. So first is congestion mapping, how you guys map the congestion, because once you have the congestion, then only you can make any service. For example, rerouting or traffic management, like smart signaling or any other thing. So second is smart signaling based on the congestion mapping. Once you get the congestion mapping, then you will do smart signaling. Third is like, for example, you want to make a smart rerouting app. So how you do it? So that one is third. The fourth is like surveillance and ADAS. Like you want to track and detect the vehicle and make the database either for surveillance purpose or just for information, providing information to other users so that they can also be also get help from that database. And third is like accident prevention. So ADAS. So you may have heard this term ADAS, advanced driving assistance service. So this is this is what I will be discussing. So first thing is data. So the data that is used in all these service is provided in layers by the big company. For example, Google, Microsoft, Bing, or Waze, and many more. So like the data is in a compartmentalization form so that each layer is uh, useful for one particular purpose. And if you want to make a complex application, then you can use below layers, and then in and then in some you can use them for making some application. So first is congestion intelligence. From where this congestion intelligence come? There are different kind of sensors that are planted all over the area. Like in India, cameras are usual these days, but apart from that, I don't think many any other sensors are there. But if you go to any developed country, so there are mm, like many sensors. For example, inductive loop will also be there, and lidars are also be there. So there are different range of sensors that can be used for gathering data intelligence. But the thing is, these every sensor will have some um, range. It cannot take data uh, far from that range. So for example, camera can see only for, let's say, 50-60 meter in daylight. And so it is point to a small part of road surveillance, not the full. But for example, you these days you are using Google Maps, and Google Maps send your data, your mobile usage data, to the Google server, and they somehow process it and give you the uh, congestion information in the form of color or in the form of estimate time to arrival. So using that, you can get the intelligence of full route, because Google is taking your data, and you are spread all over the road. You are many sensors, kind of like that. So that we called as crowdsourced data. So the idea in this particular research that I used is, can I fuse sensor data with crowdsourced data? Because sensor data has one it is reliable, but the thing is it is expensive. The crowdsourced data is kind of economical, easy to get, but it might be not robust at some time. For example, when there are not many people on that road, then Google data will be wrong for congestion prediction. So what I did is I tried to merge the sensor data with crowdsourced data, and I tried to find the color coding, and then labeling it to some label, and the details are given in this particular uh, in this particular paper, like you can see, I just published it last year. So using this, you can you can find out the congestion on any road infrastructure, either an intersection on or a road lane, and then you can use it for your surveys. So this is I have done this particular experiment in intersection in Delhi and Hyderabad. So yeah, so that is the idea about congestion tracking. Once you have the congestion, you can use it for example, adaptive signaling. So now you want to uh, optimally deploy some signal time that will help crowd to get dissipate quickly. So what you want to sense is how much congestion is there on the intersection, and accordingly you want to deploy that cycle time. So this is kind of architecture. Again, there is one paper that I have published in year 2018. You can check this paper. This is a good paper. So yeah, so in this this is the basic architecture. And for example, you can always get an idea from your studies. For example, this idea I got it from, I think, wireless communication subject of yours. There is something called AIMD, additive increase multiplicative decrease. It is a communication protocol for in TCP IP. So what I did, I kind of adopt the principle of AIMD to use to use it for controlling the traffic light. For example, there will be congestion and it will keep growing, but you want to you want to operate the cycle time such that it should dissipate. So this is also same in data communication of internet TCP/IP protocol. So I tried to leverage that AIMD protocol in here and kind of make a control policy for signaling. So this is how you can use your studies, like your idea from different subject, and mix it to get something innovative. So this is again a new paper that I published last year, transportation letter. You can get it and read it. um, so this is some experiment. I will not go in detail. So another is micro mobility as a service. So as I told you that you can provide the routing management or rerouting facilitation to some user. For example, you are a user having a mobile and you are going to a new place, but the thing is, these last 3 years, it was COVID, and you don't want to go through a COVID hotspot area. So can you avoid these hotspot area? And there are other things also. You don't want to go through main roads at that time when there was so much crowd on the main road, because workers were traveling like from the main roads to different cities. So you want to go through side streets rather than that of the main road. So this is one objective, and also you want to reach quickly. So these kind of 3 objective we have. And accordingly, we know, like if you have read about A star algorithm, is it is kind of algorithm that find out the shortest optimal path, and it is kind of very established algorithm. So what I did is I tried to give the edge weight of every link. Means every road I have give a new weight, and then this weight is given to A star algorithm, and A star algorithm will try to minimize all the edge weight in a given path. Path is like from starting to end, and that's how it will find a new route that will be following the objective that we had. So this is kind avoiding the shared location, prioritizing the streets. So again, this is a paper that I published in Rita conference. You can check that one if you are interested in this one. So this is the experiment and technical details, because whenever you are thinking to do a research, you need to prove your point. So when you are thinking how to prove that So you can go to many papers and see what kind of experiment they have done to prove their point. So this is like what I have done. Like for example, I have tried different weight and then get the average length of shortest path, and then I show that my particular hyperparameter which I have chosen is most optimal. So this is kind of experiment that you need to plan for your research work, or whatever POC, proof of concept, or uh, anything. So again, you want to you want to get a socially acceptable routing. For example, uh, in India, these kind of personal mobility devices like electric bike and this is not very common. But if you say in South Korea, like every second person will have this kind of devices. Like uh, mostly in colleges, people are coming with these PMD devices. So the thing is, again, there is uh, some kind of uh, miss like what you say ki, like they don't want pedestrian don't want that these electric bikes can use our space, because this zebra crossing or side roads, that is like the place where pedestrian walk. But now these e-bikes are using that, so there is there is need of some social acceptable routing. So I have kind of work on this idea too. And using social force model, this is one another technical detail, how pedestrian walk, and there is some modeling for that. And using that, can you make some rule policy, and using that you can like do something. For example, how much time your metro gate will be open, so that 20% can get in easily. And there is some restriction. For example, the restriction is of COVID, that every person should be 1 meter away from each other. So this kind of modeling you can do, and then get a new time for which a metro gate should open for 20% to board in easily. So this is kind of idea that you can do. So I have done something like that, and this is the details. And another thing is tracking and surveillance. For example, these days you have thousands of camera all around the city, so it is for surveillance purpose. So the thing is, this can be used for many different use cases. For example, nowadays Delhi police is using just for surveillance, to check for some anomaly or something like that. But it can also be used for many other things. For example, um, you want to uh, have some autonomous vehicle which have connected like collective knowledge of the road before going on it. So there is many traffic cameras, and they will capture the idea from like the knowledge from the traffic camera, and that knowledge is passed to a uh, vehicle that is coming onto that particular road. So this is kind of non line of sight information can be shared with this kind of autonomous vehicle. So this is also a very interesting area. So using computer vision and deep learning. So the thing is, one particular problem is how you will detect in a night. And if you know a little bit about deep learning, so in deep learning you need to train a particular model that will try to like learn how a particular things look like, and then it will try to detect it. So detection is one problem, and tracking is another. Tracking is like, given we have detected a particular car in one frame, so can we detect in another frame also? And if so, then can we connect the location? Like let's say at frame T, the position of car C was at X comma Y. So where it will be at in frame 2, uh, the same car. So the thing is, you need to detect the same car in second scene and then get the location. So this is tracking problem. So for this deep learning based computer vision things, there are so many resources available, and this is like one of the but one of the hot skill that you need to have to be in job market. So so this is one very interesting research. So for example, I did this particular thing. So the thing is, in literature, what was done is like detection is first done and then tracking. But detection and tracking, if it happens both hand in hand, then some computation power will be saved and the result can be shared very quickly. So so I will not go in detail because technically it is too deep and you need to have the understanding of how deep learning work. So kind of this is what I have done. So first I have collected the image, then uh, first thing is to collect the data. The thing is the data is of daytime. So how I can make the data in nighttime? So I created a synthetic data in some simulator. This is like, for example, you are playing GTA 5. So GTA 5 is having daytime scene that is shown, but it can also simulate nighttime scene. So in computer, like for example, you collect the GTA 5 data. So it is kind of synthetic data. So you collect the data and then you train your model on real data, then on the synthetic data, and then when your model learns how to detect a particular car in daytime as well as nighttime, then you do other things. So so then what I did is I tried to detect the feature in one frame and then in another frame, and there is something called uh, contrastive learning. This is also technical detail, so I will be like taking so many technical terms. So using contrastive learning, I tried to tell the model like okay, these two things are same when I will be training, but when I will be testing, it will be already learned. So it will tell me, okay, you have shown me the frame number n, and now in n+1 frame, this particular thing is same like that of the n. So I will kind of track it. So this is how it is doing tracking and detection at the same time. So another thing is ADAS. So I was telling you like driver advisory kind of system. So using ADAS is one of this is also one of the hot research in autonomous vehicle society and uh, computer vision society. So like how you can assist the driver uh, to like drive safely, and like these days they are working for autonomous vehicle. For example, Tesla is working, but that is far away from now, and just we want to focus on focus on how we can assist the driver. So the thing is in this one is interesting, and this is like kind of very innovative idea. So what I was thinking about is like there are some places where much accident happens. Like this is because maybe because there is some structural design fault in the road, and because of that there is so many accident happening at that particular place. So I collected the 5 year data of New York, and then I kind of cluster them. If any of you have gone through machine learning, so you can cluster uh, the the particular data which are of same kind. So I said that okay, the data which are having more than 50 accident, cluster them, and then I've got the image of those places using Google image of New York area. And then I trained a classifier, deep learning classifier, which will detect if the image is of accident uh, hotspot or if it is normal image. So once this is done, so there is another sorry again another technical term. There is something called class activation map, which is a tool that helps to find out if a deep learning model has taken a decision, then why it has taken that decision. So I I find out what are the patches that are used uh, to like classify that image as accident hotspot image, and those patches I kind of filter it because I want to notify visually to the driver on the windshield. So yeah, I need to filter them as well, because some particular accident prone feature are not of useful, because for example big building is highlighted here. This might be a reason, because if there is a big building there will be too much traffic and pedestrian going on to that building, and that might leading to accident. But what can driver do with that? Building is there and it will be there. So we need to show the AP feature that are on the road itself. So I need to filter that AP features that are the not in the context of driver, and then I calculated the projection where the driver is looking, where his head is, and then I kind of put like laser light on the windshield. And because windshield is not transparent, it is translucent, so some light will be obstructed by it, and there will be a patch on the windshield. So this is how the driver will get notified, okay, the area which is within this highlighted area in the windshield is kind of accident prone, and I need to take care of that, or I will be concentrated to that area. So this is about the data set that I was telling you. And this is again some deep learning model. I kind of uh, make it to get the AP feature, which is more kind of more interpretable, and they have some contextual information. So this is some deep learning model that I have made, and this is some result. Now again, as I was telling you, you need to prove your point. The AP feature that I have detected, I need to prove to the research community that they are actually accident prone. So how I will prove it? So whenever you think of some experiment to do it, always think how you can prove it. So what I did is I take the image, I crop the area and replace it with black pixel, you can see here, and then again put it in deep learning model, and the probability of detecting this image as accident prone drop down. So this is how I kind of proved that okay, this particular area is leading to accident. So yes, there is different metric, and this is the kind of setup that I was telling you, that there will be a camera that will be facing road to detect the AP feature. Then there will be a connectivity to facing driver, which will detect the forehead coordinate of the driver. Then there is a projector which will put a laser beam on the windshield that will make the notif visual notification to the driver. So this is the idea. So in all, like I have discussed some main application and gist of that, like what are the problem and how I try to solve it for like last 6 years. So yeah, that is it. And again, there is some new thing that I am doing. I want to introduce you that thing also. So the thing is, I am in touch with Deloitte team of Gurugram, and they are particularly keen in um like you have detected accident prone features, but what about suggesting some suggestion, giving some suggestion to the road authority, so that we can improve that hotspot, not to driver, just give some solution to us, and then we will try to solve that, and we will try to make the road safer. So they even collected the data of hotspots in Lucknow area, and then they gave it, and then I tried to run it in my model, and I worked on that idea. So this is something new, and it has not been published, but yeah, I am working on this one. So so the thing is, the idea is same. We will detect the accident prone area, and this is how accident prone area is detected, like collect the images of hotspot and then make a deep learning classifier, try to know using cam what are particular image area that is used for detect for getting like to get the AP features, to know actually why particular image is chosen as hotspot image. So the thing is, now I propose, if you have if you have known about GAN or diffusion model, like these days there are so many LinkedIn posts and so many Facebook posts too. There are many apps too. You type something and then chat GPT is one, and then you type something and then it will kind of make something like that on your on your command. So if you will put a panda and then you uh, rub the face of that panda and then ask to put the head of cat on that panda body, so it can do it. So this is something like diffusion model, and chat gpt is something like that. So this is what I have tried to do. I using the AP features, I kind of I kind of delete the AP features, and then using the diffusion model, I give the uh, command to like in paint. In paint is a process to paint inside the image where the image part is deleted to make a new image. So the thing is, I write a command. Okay, if you want to put, for example, roundabout, so paint the roundabout in that image. Uh, so this is how you will make the new images, but for that you need to train also. So I like the data was there are many problems in this. For example, the safe route design data was too less, only 6767 photo. And for example, for training a deep learning model from scratch, it need 10,000 plus photo. But if you just want to fine tune it, then also the data set should be around, let's say, 1000 or 2000 range. But here we have only 5656 photos. So there is some I explored the literature and I got that okay, there is some particular um, some particular like research which can do this, which is called as textual inversion and something like that. There are two, dream booth and textual inversion in particular, which can fine tune and then only with 6 7 images. So I try to fine tune the big model that is given by OpenAI. If you have if you are interested in deep learning and computer vision research, then you should have known this name, OpenAI. So using their model, I fine tune their model for this 5656 images, and then I give in the text to to in paint my image to get a new image that has replaced road design feature, which is kind of safe. So I run the images I'll show you. I run the new, did it for 50 images. I chose 50 images that are of hotspot, and then I remade it, and using that I put the new remade image in the deep learning model itself, which was which can give the probability. And I found out that uh, around 12% accident proneness drop down when I input the new images. So in comparison to the this in this original image. So this is kind of new research that I am doing. So I will show you. So this is kind of text that I am giving to my model, and using this text and the image with mask is something like the area in which you want to inpaint your model, like want your model to inpaint some new structure. So this is called mask. So for example, in this image, I uh, like uh, I tried to delete the area of this particular this sidewalk, and then introduce this and this and that. So the thing is, maybe I should introduce you these kind of. So these are safe road design structure. So one is called chicane. So this is kind of S-shaped curve, like kind of S-shaped. Let me show you. So these are those 50 images that if you can see my screen. So these are those 50 image, and so this is chicane. So the thing is, it is kind of S-shaped structure which will like restrict the speeding vehicle because there is so many curve. So like driver need to like decrease its speed, his speed. And there is something called choker, which is like kind of pinch the road, and then the road area will be less, so driver need to slow down. Again, there is curb extension. Whenever there is a like uh, there is a sideway meeting the road where a pedestrian need to cross near a zebra crossing. You will extend, so you will extend the sideway. So using that, two things will happen. One is driver can see where the sideway is, from where pedestrian can come in. And unless the pedestrian is not jaywalking is like going over the road, not on the zebra crossing. And second thing is like the area to cross will decrease because you have extended the sidewalk. So this is curb extension. Raised median is like you will the median, the divider between the road, you will uh, increase its height, so it is called raised median. Roundabout, you already know, there is the round circle in the road, so that will also help. So this is kind of uh, like the particular safe road structure that are used. And so using this, like for example, I can show you this image. This in this image I have put a particular choker here, and then in this image the curve extension, and there is something called street plaza is this kind of thing. You will put some benches, some flowers, some vegetation near the sideway, and you by that what will be the feeling, driver will think that okay, this is the side road and not the main road, because there is some flowers and something, so there should be some children playing, and I need to uh, decrease my speed, or maybe I can hit some children. So something like that kind of ideology will develop in the mind of the driver, and this is how street plaza help to uh, like is reduce the speed. So there are like 50 images, and there this is also some vegetation near around side. Uh, there is roundabout. So like that, there is 50 images, and you can see it. So yeah, that's all. That's all. Like I show you this one. And by the way, like for this particular research, I'll request you to fill the survey, because like I am doing this research, so I need survey like how humans can get this. For example, you will see the original image in this. You will see the original image, and then you will see the new image. And on a scale of 1 to 10, just mark what you think, how much safer is this new image. So if you think it is most safest with respect to the original image, because anyway this is a big highway and I can't make it the safe like your house, but yeah, I want to make it safer than that of the original one. So I'm trying to save it, making it safe by putting a roundabout in the new image. So you can select score between 1 to 10. 10 is for most safest, and 1 is like the original one. So, and how much time you take it to take to recognize the change. And another thing I forgot to tell you, the another thing that I do is um, saliency enhancement. For example, if driver will see the structure which is kind of making the road safe better or quickly, then he will be like more attentive and can avoid accident. So these kind of new things should have the color which is kind of out of the like picture, like kind of it will be more silent and it will be more recognizable when you see it once for let's say 1 second. Then that particular architecture should be more silent. So so I'm asking another question. How much time you take 1 second, 2 second, or 3 second to find the difference, like to get the difference? For example, here there is this image, and here it is the raised sidewalk. So raised sidewalk will uh, help the driver not to go onto the sidewalk and get into the accident, so something like that. So you just judge on your own and then give like give the survey, because this is ongoing work, and if you guys will give the survey, then of course you are helping this cause to avoid accident. And you know how bad this is, like around 3700 people died daily on accident in all over the world. So so yeah. Let me give you the link for this one. So this is the link. And what is PWD? Sorry, you can PWD. Can you point out where I asked, where when I said this word PWD, so that I can get the context what you are asking? What is PWD? Lokendra? Maybe. So, anyways, this is the form.
Okay, thank you, Sumit.
Yeah.
So, yeah, thanks for sharing your research and telling students about your research. And now, if anyone have any query from student side, you can write in chat box. And Sumit has shared one survey form link in chat window, so you can also fill that. Okay.
Guys, please do fill it. Like you will be helping this cause, because I am directly working with Deloitte and some other like government in Karnataka also, as well as doing my research. So like your feedback can help them as well. So yeah, do help uh, for this cause.
And moreover, if any student wants to join this type of research, maybe they can consult Sumit. So you can tell me. Is it okay,
Yeah, yeah,
Sumit? Ask
yeah,
you.
yeah. You can reach me out through this email ID. I'm giving you my email ID. If you have some idea or you want to talk something, then you can mail me, and I have shared my email ID, and I'll try to reach out. So
Right. So if any query is there, you can post. Otherwise, we can close. If we are fine. So Sumit has also given his email ID. If you want to do research in this field, you can. He's the master. Okay, you can contact him directly, or you can contact him through us, through me. Okay.
About this survey, like it is open maybe for 2 days, 2 more days. So yeah, feel free to like fill in within 2 days, because yeah, I need to close it and then summarize my work. Okay then.
All right,
Any
Sumit,
more thing?
I will post this link in their channels or in our
Okay, sir.
student group as well. Okay.
Okay, sir. Thanks.
Okay. Thanks everyone for joining. You can carry on with your regular class now. Thanks, Sumit.
Thanks, sir. Okay.
All right. Bye.